I'm going to be sharing a little bit about Playbit. It's a local first operating system. We are a team of 4 people. We've been working on this for, I would say, about 4 years, give or take, something like that. We're currently in an alpha sort of stage. There will be a link later on where you can go and just grab a copy if you want to play around with it. First off, before I start, thank you so much, Chad, for making me feel like not a genius. Yeah, it's truly no, I'm kidding. It's truly an honor to be in front of all of you. I feel very much inspired personally by so many of you here. I met so many amazing people already in just these few days, and I'm looking forward to meeting more of you in these next 2-3 days. Okay, so why even, why am I even here? Why did I even start working on this stuff? I worked on a lot of local first stuff, actually. Spotify, I was one of the very first people working on Spotify. It was a local first thing. It was like this crazy technological thing, actually, peer-to-peer, not hole punching, the whole very, totally overkill, right? Totally overkill. Ask me about the story about the Swedish nuclear power plant that had to call us in the middle of the night. Facebook Messenger, I worked with GraphQL. I was on the founding team of GraphQL. I worked on some research and development at Dropbox on a new type of file system there, also a local first kind of thing. Figma, I worked at Figma for 5 years. A lot of the inspiration on how we're building Playbit comes from how we built Figma, hopefully with some lessons learned and baked into it. And yeah, since 2020, I've been working on Playbit. So this is roughly where I'm going to take you today. First off, I'm just going to spend just a few minutes talking about what Playbit is. Then I'll dive into a little bit of the philosophy that we're using in our team as we're developing Playbit. After that, me and a colleague who is on the line right here, he couldn't make it. He is sort of like my partner in crime with Playbit and built a lot of the GUI of our desktop system. Is on the line right here. He couldn't make it to the conference, unfortunately. Maybe next year. We'll be doing a live demo, so we'll see what demo ghosts comes out. At the end, I'll talk a little bit about a practical application of this philosophy that we have. So in this talk, I'm trying to not be prescriptive. I don't have any answers, and I definitely don't have any answers for any of the things that you're working on. Yeah, let's get going. Okay. Yeah, so what? Yet another operating system. It's just take some Wayland and you throw in some new stuff and here's a gigabyte of stuff that is moderately different than something else. No, it's none of those things. We do use the Linux kernel, but that's about it. We're as much Linux as Android is Linux. Here's a screenshot that I took yesterday. You just get a taste of it. You'll see a live demo later, and it's going to look like this, roughly. So it is a desktop environment. It is graphical. It has some weird quirks. It has a lot of things. There's a lot of things it doesn't have. It has mostly it's lacking things. Okay, so yeah. So thanks for being here and helping us build this stuff. Now, Playbit is really for people whose paintbrush is software. This is how we think about ourselves, our audience. This is kind of our niche, right? We're not trying to displace macOS or Windows or iOS or anything like that. That'd be crazy. It is an alternative mental space. I can get into this later if anyone is curious. Hit me up after this talk and we can dive into it. There's a lot to this of where we are physically and mentally, I think very much affects our sort of creative spirit and what we build. If every day you sit down at your same desk, in the same room, in the same display, you open up maybe VS Code or something, you write, I don't know, maybe JavaScript and stuff. And then comes weekend, and you have this idea you've been thinking about for weeks, and you're like, yes, I got a full Sunday. Are you going to sit down at the same desk, the same computer, with the same tools to build this new fun thing? That's a really hard thing to do, I think. And so that's part of also how we shape it and why it's an OS in the first place. We're trying to build computers that transcend hardware. Think, I have a laptop here, I toss it in the lake. I buy a new laptop. I open it up, and everything is there. Text selection windows, fully stateful. And this is part of our big local first challenge. So there's no cloud in Playbit. We want to, because we're a small team and we're accomplishing to do something relatively large, we have to be very focused, and we're trying to create something that's rather simple, and have our audience, our users, make fewer but more interesting choices. And I think we need a fresh start, you know. There's been decades of this pursuit of industrial scale in software, and that's benefited a lot of us. And some of the companies I mentioned earlier that I've been grateful to work at has been, you know, on the receiving end of that industrialization of software. But along those lines, I think we have lost a lot of things. We've lost, I mean, I'm preaching to the choir here, right? We've lost, you know, the personal scale software. It's now quite hard to pick which of these 220 AWS services I need for my, like, 10-friend homepage. Like, you probably don't need any of them, but you know, you're gonna spend a whole Sunday just picking that thing, like which database to use. And then you spend 2 weeks just getting your app on the App Store. And like, who has 2 weeks for like a fun app with friends, right? Okay. So that's a little bit about what we're doing. And now I'd like to talk a little bit about the philosophy that we apply to this. I'll touch on just a few things here because we don't have a lot of time. And so again, if you're curious about any of this stuff, I can share more material. Happy to have conversations about it. Another way of thinking about our philosophy is like our first principles. The first one that I found the most useful through, you know, my career and my hobbies is this concept that if we do things really, really well, we will be 80% wrong. And with this, I mean, take something you know that you consider successful, and then you think back to some point in time early on when the people or the person who built this thing said, I have a plan, I'm gonna build this thing, right? And some time passed, and the thing was successful in your definition. I promise you that that's like 20% or less matching that plan, the thing at the end. Everything that I've ever worked on, Spotify, Figma, stuff at Dropbox, Facebook, none of them started out the way it eventually shaped to become something that people found interesting. So when we write code, we're like, yeah, code doesn't matter. Like, it doesn't make, code is just like, it's just the printed words in a book. It's not the story of the book, right? Throw away code, make code, throw it away, have as little code as possible. Speaking of code, something we really believe in is to own or control your source tree. And so I'm going to show you just like 3 different aspects of owning your code versus using someone else's code. Right? And I'm not saying here again that I'm not prescribing any solutions here. I'm simply sharing our philosophy, and feel free to just say, like, that's bullshit, you're wrong, and that's absolutely fine. So the first aspect is writing your own stuff has a high upfront cost, right? There's no doubt about it. I think this is one of the more significant like downsides of writing your own stuff. But there is a very significant upside as well. If you write your own stuff, you have a deep understanding of it. And this is not something I think we should take lightly. If you pick someone else's code, right? Even if it's just like copy-pasting source code, if it's using a library, whatever form it takes, you have to understand that code in order to build good stuff, right? It's not that you can just use someone else's code and just say like, I hope it works, right? Because most of us here, if not all of us here, have been in that situation. And then a month passes, a year passes, and then shit breaks. Excuse my French. Now we have to go and learn about the thing, and it takes us months, and sometimes it takes us just too much time. We have to rewrite it at that point. So there's a lot of value in this. Finally, writing something or owning your own source tree, so to speak, allows you to make changes really quickly. And with this, I mean, like, there's a bug somewhere, or there's a behavior you want to change, right? For us, for example, we've written everything you see from text rendering to, like, how things are drawn and how applications work and everything, we've written ourselves. If we want to change something, then we just make the change, we rebuild the system, and there it is. There's no, like, pull requests and waiting for someone else to, like, accept that or maintaining patches or any of that stuff. Next up, I think complexity grows. This is just a universal truth, right? You start with something, and then time ticks on and complexity grows, there's no way to fight it. It's entropy, essentially. And I think in many ways, we always fight entropy, right? We clean our kitchen, hopefully. And this is kind of like the equivalent in software, right? We always try to like kill code we don't need anymore, simplify systems that are growing complex. But the fact is, everything grows in complexity, and so we're always trying to start simple. Instead of building 3 things that we know we're going to need, 3 different implementations of, we build one thing and we try to sort of like, use it for everything else. The other aspect is performance. This is kind of a controversial topic. I've had countless conversations about this, and there are different arguments in many different directions here. I and we at Playbit believe that it's very expensive to add later on performance. And I don't know how to sort of phrase it, but you can sort of like start thinking about it as you got on one axis kind of flexibility, and on another axis like simplicity, right? And performance, I think, is like not really valuable in itself, but performance is one of these like ingredients in the soup that makes it taste good, right? It's like one of these things that enables you to later have like a responsive UI, for example, right? Or something that costs you less money to operate as a company, and now you don't have to, now you have either more time, right? Or you have to ask for less money, or whatever it means. These are good things. Okay, so I'm going to attempt like a speed run, basically, on a definition of quality. And quality, I think, is such a elusive concept. And if I were to just ask 5 people in the audience here about what they think quality is, I would get 5 different answers, I think. But yet, everyone here, if we got into a conversation together and we talk about quality, everyone was like nodding heads, like, yeah, quality is awesome. And so I think we all care about it, but it's really hard, almost impossibly hard to quantify. When I worked at Figma, we had this really deep sort of like admiration for quality, and it was something we talked about daily, about quality. In the 5 years I worked there, we never found a vocabulary for quantifying it or for talking about it in a way where a new colleague joined the company would be like, oh, quality, let's share our values and beliefs and why quality is important. And then like 3 months later, they were like, okay, I get it now. Not like 3 hours later. So 4 aspects here. First off, I think quality is something that's reliable. Right? Reliable meaning sort of like it always works. Something that's cohesive. If you do something in one place, you can take those learnings so you can apply it in a different place. Many people there probably use like a good old terminal, something like Bash or C Shell or whatnot. These things are very cohesive, right? It's like most commands use curl here, use JJ there, use git there, and they're all sort of like, they're quite cohesive in the way you can learn to use one, you can apply a lot of at least the superficial aspects of it are cohesive. And third, it's responsive, and this ties back to quality, performance that I was talking about a minute ago. And lastly, I think there is some polish to it. And yeah, shout out to all the Polish people here. I'm talking about like polishing a surface. A really great quote that I love is this: people come for the features, but they stay for the details. And I think it's there's some deep truth about that. And a few more slides here, then we're going to move on to a live demo. And we'll be very nervous if it's going to work out. Affordable quality, okay, so now I say quality, like, awesome, cool, but like you can either do a few things or many things, and like it's really hard then to also make it qualitative, right? That just means more effort. And so I think you have to think about what is affordable quality, right? Otherwise, you're only taking on cost. And so I think what it essentially means is that when you're learning, you do many things intentionally poorly, right? And intentionally poorly here means many things. It can mean like you use whatever feels good to you. Don't care about what program language it is. Whatever gets the thing going, right? Maybe you're not even programming yet. Whatever you do, you throw it away. You don't use any of it after the fact you learn something. And then you find a few things that you either identify through learning or just know ahead of time are going to be sort of monumental or key aspects of your thing, and you really double down on that. There's a lot more to this, of course, but yeah. And so really focus on the parts that users touch. And it's hard with computers. It's an abstract concept, right, in many senses. You can think of something like a bicycle or a car. And what are the parts on a nice bicycle or basically any car? Where are the really like high-end materials? They're going to be in the steering wheel, right? And if it's gear shifter, it's going to be gear shifter and these things. Then you look at like the material in a car or something like that that's like by the footwell, and it's like these low-density plastic that costs like nothing, you know. Similar on a bicycle, right? You might have like really nice like handles for your hands. And so there's a similar thing in software, an area where users are touching stuff. Okay. Longevity. How can you run this once I'm gone, right? Or once the company is gone, once I just like don't want to work on it anymore. So much software today, especially centralized software, is on the far edge of like, no, it's not going to work once it's gone. It's like this immediate thing. You all know what I'm talking about, so I don't need to explain it more than that. This means a lot to us. We're trying to figure out how to make Playbit work and function once Playbit is gone. That might be in 100 years. It might be in 10 months, right? Who knows? As a user of any platform, you want some sort of guarantees to some degree of these aspects, I think. At least I do. And how much effort do you put into longevity, right? Like early on, because you have these 10 things you want to build, and you know you only have time for 3, and how are you going to fit in also taking all this cost of quality and making it fit into the long now idea, right? It's really hard. And so it's just like a good question to ask, like, what parts of the thing I'm building do I put effort into? And finally, before the live demo, and Edward, if you're still listening, we're soon up, buddy, is to this idea to degrade gracefully, right? So for example, with Playbit, we have some servers that helps with authentication and communication. And once those are gone, you can still use Playbit, but it won't be able to connect to the servers. And so some functionality is not available. And that's a way, another way of thinking about that, the opposite, is progressive enhancement, which I think is pretty popular in many ways. And this is kind of the inverse of that. Okay, and finally, I'm just going to leave this on here. I'm going to take 30 seconds to start up Playbit here locally. These are just some of our guiding principles. We have these printed out, and we look at these together sometimes as a team. Let's see here. And I'm going to see if I can get this over to a different display. It's always fun when you have different display here. Let's see. Well, this is a bit of a struggle, I'm afraid. I might do this. I am sorry about this. Multi-monitor situation. I'm going to do this and slide this guy over here. Okay. And what I'm going to do, I'm going to very awkwardly like turn around a little bit because I cannot see what is happening from where I am standing. But, you know, I should know about this. Oh, yeah, of course, we have a very interesting graphics bug here. I'm just going to close this out for a second, Edward. And I'm going to change the scaling factor here a little bit. Actually, this is going to be fine. We're 100% already. Okay, Edward, let's do this. I think if you want to talk, Edward, and just say hi to the audience, they should be able to hear you.
Hello?
They can hear you.
Great.
Yeah, big applause for Edward. He is. I wish he could have been here next to me. Okay. So this is Playbit running live, and I hope nothing breaks. So we're going to show you 2 things. First off, Edward, who is in the UK currently, will open up a file browser, and then we're going to just build a program from source. That's a little game, and we're going to play the game together. And see if I can win over Edward in tic-tac-toe. He's pretty sharp at tic-tac-toe, so we'll see how it goes. Okay.
Yeah, so I'm going to go into my file browser, which hopefully you can all see. And I'm going to open up the project for tic-tac-toe.
And I can get in here too.
Yeah, so we've got the source here. It's just over 100 lines. And we can click the play button, and it'll build it.
Oh no! Oh, he outsmarted me, but maybe. Oh, damn it! Okay. And thank you. And if we go back to this window, we can see, so this is actually running on Edward's computer, yet I can interact with it and scroll around here. I can select text. And this program is not, there's nothing in this program that is specific to local first. There's no special database it uses or anything like this. The system just kind of does it for you. So we get two different kinds of programs. One we're not going to demo today. This one is sort of like, it's automatical. You know, it has limitations, of course. Okay, next we're going to, and this time I'm gonna drive it. I'm gonna just close the window on Edward's side here. So before I go further here, I can show you real quick. This is actually Edward's file system. You know, I'm not gonna go into his home directory. That wouldn't be right. But if he has something in here that I wanted to look at or grab, I can just do that. It's kind of cool. But he has to open it, of course. So there's something right there. Okay, let's see. I think I know where I'm going here without actually seeing what I'm doing. I think this is right. Yeah, this looks about right. So what we're looking at here, this is a different. It's not a game. It's just a little like demo program. When I start this up. We're going to see a bunch of bouncing balls. And here I'm going to show something that we call these live variables. If I can get to it. So first off, we're just going to reduce the energy retained. Now I'm going to restart it here. So that, it's very hard for me to navigate with the mouse like behind my back. It's a very interesting experience. So if I'm trying to be a little quicker here, since there's a little bit of a physics simulation. I'm going to just do this. And, okay, one more attempt. I think you get the point. We're going to try one more time. And you see, Edward is here, and for him, he has the same experience. I'm going to start with just reducing the gravity right away, because then things get more interesting that way. Yeah, so these are just like globals. This is nothing like special. We just have a couple of variables here. And then we have decorated them at the end. Oh, Edward is selected. Yeah, you go for it, Edward.
Yeah, so these three variables here at the top, these are being controlled by these sliders. And if you scroll to the code at the bottom, then you can see that this is how these variables are then set up so that you can modify them from within the IDE. And the app only had to write these 3 lines of code to have these variables modifiable.
And we have an integrated debugger. We can just set a breakpoint at any point in time here, which I can try. I'm not going to do a full debugging session with us here. We don't have the time, and you probably don't have the interest. But let's see if we're going to put something in. We'll put it in here, for example. It'll just plop us right in here. We can go in and we can have a look at bolts, for example. And now we can just explore this data structure. And this is just what's in memory. There's no frameworks, there's nothing special here. You know, you're an operating system. You can just like go and poke at, you got control of a virtual memory. You can look at the ELF that this is baked into. Yeah, so thank you, Edward, for hanging out here, doing this demo together. I'm going to shut down the system if macOS lets me. Let's see, we're going to do shutdown there. Okay, say okay to that. And we're going to get back to the presentation. Thank you. Okay, so I forgot to advance to the slide where one of us is sweating and the other one is very excited. Yeah, so you can go here. You can just grab a copy. If you have Mac OS, we have like a first-class experience with a GPU bridge baked in and everything like that. If you don't have Mac OS, you can just grab a disk image. You can run in QEMU on any system that has QEMU. There's also Discord on this webpage. You can find a lot of information on this page here. But don't expect too much. Okay, second part of this. I'm going to have to speed up a little bit because I realize that I am talking way too much and not fast enough. I don't think you want me to speak fast, so I'm going to speak a little less and move a little faster. Okay, so an architecture, sort of like a practical approach to this philosophy I was talking about before. Now you send a demo too. It might make things a little bit clearer as well, what this thing is and what we're trying to do. Okay, so first off, storage. I think one thing that's very important is to figure out what the granule is for syncing, right? Is it like a cell? And I'm just using sort of a table database type of language here. Yet it could be anything, right? I'm not prescribing any data storage here at all. Is it some sort of cell? Is it a row? Is it an entire database? What is the thing you're syncing? What if I have 5 terabytes of data in one database, but my device has 2 gigabytes available, right? What is the transactional boundary? And this kind of goes in, and thank you, Johannes, for talking this through with me the other day. The transactional boundary, you got to figure that out. What is that? I think it's tightly tied in with what the sync granule is. The storage, this diagram, I've drawn this, I don't know how many times when we have conversation about these things at Playbit. Usually things look like this. Usually we start out in the bottom left corner when we build something. And then I think if we have a mental framework of I'm building a library, we're very quickly going up to the far right, which is danger zone. That's Indiana Jones stuff, Many things will eventually get there. I think most things in practice actually ends up having different solutions for things that align up in the right corner, specialized solutions. To be very clear about what I'm talking about here, let's say that you have small messages. That happens very often. You saw these bouncing balls in our demo. These are small, tiny messages sent over the network, essentially, that synchronizes their state on the 2 different computers. High frequency, small things. Not that hard, but constraints around latency. And then you have big, chunky things, let's say you have files in a file system, and they're images, and they're a couple hundred megabytes each or something like that. Latency is not as important as consistency, for example. And then, of course, you're going to have the top right corner. So just be aware of this. I think it's very easy to just try to solve for all the possibilities in the world, the top right corner, but then you'll never get done, or it'll be so complicated that no one understands it. We have found that files is a special thing. It just warrants a dedicated model for us, for example. Structured data, one model. Files, a different model for syncing and storing. Speaking of syncing, I'm not going to go into this deeply because there's a whole room of people here thinking about syncing, I think. A key aspect is, of course, conflict resolution. And with that, you got to figure out, am I going to merge stuff or am I going to replace stuff? And for us, in our framework, we're thinking that a file is replaced, that a directory is merged, kind of a union, and a data structure is merged, and an item in the data structure, we kind of give the application the possibility to say, hey, I want to do it in a certain way. And in reality, this is a little fussier and applies to data structures too in Playbit, but this is roughly our framework. Access and permissions, I think this is a big part of just how do you put data into different computers and have them be the same or feel the same, right? How does this even work? I know that there's a couple of very interesting people working on KeyHive, for example, which one take on this. Very inspirational. Another axis here is to think about where do we put this access and permissions? Do we put it sort of on the smaller scale of an individual item, all the way to a full database, a document, for example? You got to think about the authority in a distributed system. This is a huge question. This is really, really hard to solve. I don't know if anyone has actually solved it. Consensus is one solution, but that's not a solution. It's more sort of it gets the job done, but it doesn't actually fully solve it. In Playbit, we have a centralized authority. You can make your own centralized authority, kind of you could with BlueSky or something like that. We don't use that AT protocol at all, but encryption, think about the isolation of concerns. I think that's really what encryption is about. What is the boundary of, let me advance my slide here. What is the boundary of encryption, right? Is it on an individual item? Let's say you had one of these games that we demonstrated. Do you have encryption on like the whole desktop that Edward and I shared? Do you have encryption on the application itself? What if many people play games on this app, right? And maybe a session inside that game is what you want to encrypt. In Playbit, it's hierarchical. We have this concept of an instance, like a system, essentially an installation. And then an installation can have any number of these kind of virtual machines. We call them workspaces. And inside each, there are many applications. Each can have a session that's encrypted. Distributed or centralized? Tough question, right? If you go full centralized, you put a server in there. It's like the cloud thing. I guess most of us here are like, let's not do that, or like, let's do that with a twist. On the other far end of the spectrum, top left corner, is like fully distributed, right? Peer-to-peer, lots of hard problems to solve. And when I say cost here, I'm not talking about money necessarily, but just like the human effort and the time required to build something like this. For us, we believe that there's a hybrid model here that's just right for most solutions. This is what we did with Figma. Figma uses, I think famously at this point, kind of a CRDT technology, but it doesn't really matter if it's CRDT or not. It's like this really sort of just like very pragmatic approach to the problem. In practice, Figma is much more closer to the server than it is to the peer-to-peer though. Playbit is closer to peer-to-peer than to a server, but there's still some servers. We found this to be a really good trade-off between the complexity and then the cost of building something versus like the user experience at the end. And operational costs. Sorry, let me just point that out really quickly. I'm talking about servers here, right? You put a big server, let's say you do something like Figma does, and for every Figma document you have open, Figma opens that document on a server, right? Now you have 1,000 people, and you're like, wow, we're growing in user numbers. And you have 1 million people, and now you have 1 million people times 10 tabs each person. You have 10 million documents on your servers. And you're like, server bills are going to be, create some sweats in the forehead. And so this is kind of our ethos, you know. We kind of take a decentralized model, we sprinkle a little centralization on it. I'm not going to pause on this slide, so you can take a photo, or you can get the slides later. So I'll leave you with this. I think that there's a lot more to syncing than syncing. There's sort of like what's the general like system design of the whole thing, authentication, encryption, right? And the practical aspects of like at the end of the day, all of the stuff I've been talking about is all in service of the user experience, right? Like we're not building what we're building with Playbit because like it's like a beautiful thing. We're building it because like we want to make a difference to a few people out there who is using a paintbrush that is computer programs. So thank you very much for listening. I really appreciate it. And thank you, Edward, who's here, sort of like, imagine Edward standing next to me here on the stage. I want to point out, we are hiring. We are a real company. We are a remote-first distributed company. And we love technology and people and fun things. So thanks so much.